Greetings, math fans. All right, so this is day 7 of vector applications, and it's basically the same as day 6. Everything's identical except I just changed some numbers and came up with 4 more problems. So let's do it. First problem, a 200-pound force makes an angle of 55 degrees with the second force. So if you guys remember when we drew this one, this is going to be another parallelogram. Okay, so this is your 200-pound force, which is your first force, and it makes a 55-degree angle with the second force. And the resultant of the two forces makes a 15 degrees, so let's draw a parallelogram here. Okay, so there's a resultant. And so it makes a 15 degree with the second force. So let's make sure you just draw in the right place here, right? So this is 15 degrees. It says find the magnitudes of the second force and of the resultant force. So we'll just call this one X and this one Y. All right. So, you got to use your properties of parallelograms. So that's 200 and this is 200 over here. Opposite sides of parallelogram are congruent. If that's 55 degrees, that means this angle right here is 180 minus 55, which is 125 degrees, right? Because consecutive angles of a parallelogram are supplementary. And remember I told you, this is 15 degrees. If that's 15 degrees, that's 125. That means the total of that is going to be 140. And then, of course, then this angle right here is just going to be 180 minus 140, which is 40 degrees. Okay, so it's pretty easy. So if I redraw this picture here, I get 40 degrees, I get 15 degrees, 125 degrees, and this is X, this is Y, and this is 200. Okay, so you have an opposite side angle ratio, so it means we're going to use law of sines. So law of sines. Okay, so first one, let's find, I guess we can find X. So 200 over sine of 15 degrees. That's our side angle ratio that we know is equal to X over sine of 40. Cross multiply, and X comes out to be 496.7 pounds. Again, don't forget your units. Okay, so that's our second force. And then same thing, 200 over sine of 15 degrees equals Y over sine of 125. Cross multiply and solve, so we get Y is equal to 633.0 pounds. And that's a resultant force. Okay, really pretty easy. Again, just kind of think about it logically. The resultant force is going to be some combination of the two forces together, the 200 and the 496. Obviously not equal, the sum, but something a little bit less because the angle between the two forces was only 55 degrees. So, but of course never to be greater, because if you would be equal, it would be like a tug of war. You certainly can't have it greater. Okay, pretty easy. All right, number 2. You're pushing a 5,000-pound truck up a hill with a 60-degree slope. How much force is required to move the truck? So, guys, remember, this is just like our nice little friendly problem here we did before. This is our truck, and this is 6 degrees, and that's the weight of the truck is this way. So it's 5,000 pounds. And remember, you're drawing it like this. Okay, there's your right angle. Okay, because remember this angle, which is going to be basically 90 minus 6, right, which is 84 degrees. So that angle, and not that it really matters, and this angle are congruent, just to kind of put it in perspective here. So this is our right angle right here, and that's 6 degrees. That means this is 6 degrees here. And that's really what I want. I want to know that's 6 degrees. Because what you're trying to do is, here's your force, which is this force right here. right? And that's what we're trying to find. How much force is required to move the truck. And remember what we're doing is we're using right triangle trig because, again, we could use law of sines, but why make it difficult? We have a right triangle here. Okay, and so we use right triangle trig. So write the right triangle trig. And we have sine of 6 degrees equals opposite over hypotenuse. So f over 5,000, cross multiply and solve for f, and f comes out to be 522.6 pounds, which actually makes a lot of sense because it's 522 pounds is, it's obviously a lot less than 5,000 because you're going up a 6-degree slope, so certainly going to be a lot less. And think about it though, if it goes up to, as it goes up more and more and more, if it would go up to 90 degrees, it'd be like the whole car on top of you, which means you're pushing 5,000 pounds up. Okay? All right, so those are, I think, the easier of the problems. And then we switch to the next page here. I think these are a little more challenging, but they're not bad once you practice them. All right, so a plane flies 500 miles an hour on a bearing, whoop, 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 of 215 degrees. So let's do that. 215 degrees, which means it's going this way. And it's 500 miles an hour. So label it here. Okay. A 30-mile-an-hour wind from the direction of 270. So it's another bearing. So if you want to go do your boop, 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 you can. Whoop, whoop, whoop. I'll just do it for you. And anyway, it's 270 degrees, but it's from a direction of 270. Remember I told you, if you're not sure about that, say, gee, I'm coming from the north. That means I'm going south. So I go to the north, I go the other way. So if I'm coming from 270, I go to 270, which is left, but I'm coming from the left, so that means I'm going right. So it's from 270, which means going that way. Okay, and if I actually put my angle here, this is 270 right there. And it is 30-mile-an-hour wind. Okay, so that's your drawing. And now what's going to happen, remember you can't do tip to tip for a vector, so we're going to move this vector over here because it's actually blowing it out of the way, right? It's blowing to the right, and then your resultant vector is going to be like that. Okay, so let's label this again. This is 30 here. So what I told you guys, I think was the easiest way to go about doing this problem is, remember, you extend this one vector, the vector of the airplane, extend it down like that. Oh, look at that, it's sweet. Because then what happens is, let me draw this in a different color. If this is 215 degrees here, that means this is 215 degrees there. Okay, and if that's 215, so let me make this in green. This is the other vector. This is the 270. Just think it's so easy. You can even see it, right? It's 270 degrees. So 270 minus 215 gives me this angle right here, which is the same as the angle inside the triangle. Oh, that's it. So if I redraw this triangle, let's just subtract 270 minus 215 gives me 55 degrees. Okay, that's the angle between those. It just makes it so much easier. So if I make a quick sketch now, this is 55 degrees. This is 500 miles an hour. This is our 30-mile-an-hour wind. And I'm looking for x and the angle, right? It's going at 215 degrees. I'm also looking for theta here, because that's going to tell me which way is it blowing. So we'll do that the ground speed first. We're going to just use law of cosines. So we got x squared equals 500 squared plus 30 squared minus 2 times 500 times 30 cosine of 55 degrees. So x is equal to 483.4 miles per hour. Don't forget your units. Okay, that's your new ground speed. And you can tell that it's going 500 miles an hour, so it has a little bit of a headwind because it's slowing the plane down. So now let's figure out that theta. We're obviously going to use our value of x as a stored value. Remember that. So you could store it as x in your calculator. And so we basically have 483.4 over sine of 55 degrees is equal to 30 over sine of theta. Okay, and we do all our cross multiplying and inverse sine, and we get theta is equal to 2.9 degrees. So now the question is it blowing it less degrees or more degrees? Well, look what's going on. The wind's taking this vector right here, right? That's the original vector of the plane, and the wind's blowing it this way. So our new vector, being this, is less of an angle. So it's 215 degrees minus that, minus this theta right over here. Lots of colors. Okay? And so that's what we're going to do. We're going to say 215 degrees minus 2.9 degrees, and my new angle is 212.1 degrees. That's my new bearing. Okay? Really not bad. Just gotta, I think extending that line really is a helpful thing there. All right, so let's do our last problem here. It's another airplane problem because I think they're just the more challenging of the two. And this problem is just a little different as well. So a plane flies 500 miles an hour on a bearing whoop, 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 of 65 degrees. So let's do that. So 65 degrees. And it's traveling at 500 miles an hour. Okay, a 30 mile an hour wind, so it's going to blow against the plane again. It's always does that in the direction of 25 degrees. What does that mean? Notice it's highlighted. It's got an underline around the in, or underlined around the in, because it's blowing in the direction of 25 degrees. So it blows in the direction of 25 degrees. Again, put the word north in there. If I'm blowing in the direction of north, that means I'm actually going north. So if I'm blowing 25 degrees, I'm actually going this way 25 degrees. If I was going from 25 degrees, it'd be going down and to the left from 25 degrees. Okay? So that's what's given here, and then I have my resultant vector, which looks like this. Okay? So put an arrow on that. All right, so remember, we're always going to use the 25, or both the angles, so the 65 and the 25 degrees. This one's just a little different. Does it really help you to extend it? Nah, not really. It's almost like a little bit different problem. So that's what I'm trying to tell you guys. There's so many ways to solve these problems. So how am I going to use that? Look at the parallel lines. Let me put, this is 30 miles an hour here. So I'm going to find this angle here, guys, right here. Got to use that 65 and that 25. Well, again, think logically. Do you guys agree that 65 degrees, so let me just highlight it with red, that 65 degrees is, and this angle right here, what can you tell me about those angles? Well, they are same side interior angles, which means they're supplementary. So that red angle is 180 minus 65, which is 115 degrees. Okay, so if that's 115, well, we're almost there. That's actually really nice. If that's 115, and I'm giving you guys that this is 25 degrees right here. So 115 plus 25 degrees gives you 140 degrees. That's the angle inside the triangle. That was actually easier than the other kind of problems. Okay, so let's sketch that real quickly. So this is 140 degrees. This is 500, and this is 30, and I'm looking for x. So law of cosines, of course. X squared equals 500 squared plus 30 squared minus 2 times 500 times 30 times cosine of 140. So you get x equals 523.3 miles per hour. Pretty easy. So that is our ground speed. The resulting course, well, think what's happening here. What is, if this is the plane, and the wind is blowing it it's truly blowing the plane. Let me use a different color here. The wind is blowing this way, right? So it's blowing at what's going on with the angle. Well, if this was 65 degrees right here, the whole thing, isn't this line here less of an angle? Isn't that angle less? And so what I'm going to do is I got to figure out theta, and once I get theta, I subtract it from 65 degrees. So let's use law of sines. So we're going to do 523.3, which of course is stored in x because you never use a rounded value, over sine of 140 is equal to 30 over sine of theta. Do your cross multiply, inverse sine, we get theta is equal to 2.1 degrees. Now this is again where you subtract. So it's 65 degrees minus 2.1, which gives you 62.9 degrees. That's our new course. Okay, so there, move it up a little bit. Okay, 62.9 degrees. All right, so again, this is just the same stuff as the day before. It's more practice. You guys have a few more, another worksheet, I think 2 more worksheets with more practice problems, but you guys have to master this because the test has lots of application problems on it. Okay, and you got to be good with it. In fact, you're going to have probably one of every type of problem on there. Probably one where there are 2 forces, probably one where there's a force of something going up a hill, definitely an airplane problem. You have a first force and a second force. So there's one of every type of problem, even a going off course, right? You're the one with Math Island from the last worksheet. You're going off course and you're traveling, this for 20 miles and then this course for 10 miles. What's the resultant course? A lot of different types of problems, but you got to know how to do every one of those, and they're not difficult. It's just practice. All right? So that's it, math fans. Have an outstanding day. Adios. Goodbye.